All right, so we're looking at separable differential equations. So previously we've done differential equations of the form dy dx equals f of x. So we talked about that's when we just have a variable of f of x. Now, these separable differential equations are ones where we have a function of x and a function of y here. So and I've got a few examples down here. So let's just go to my pen. So this first one here, we've got x equals dy dx equals x times y squared. So the f of x function is just x, and the y function is y squared. So you've got these two functions multiplied together. This next one's a little bit of a tricky one in that you've got to consider, and the next step will make sense later, that this one here, we've got this bracket times a constant. So our f of x function is 1, and our y function is y squared plus 3. Now, this one's a little bit tricky because in the second step of this that we're going to get to soon, you're going to have to multiply by to get rid of this, and you can't just take y from both sides. And maybe I'll show that in the next step. This next one here, we've got x plus 2, and then our y function here, our gy, is 1 over y cubed. So we've got those there. Now, the point of this is, and I've just written this down so it was ahead of us for the notes, is that if we have these separable functions, we can multiply by our reciprocal of these. So this function, we're going to cancel it on this side, get it to this side. And then if we integrate with respect to x, we end up with this dy dx is here. Okay, so we're integrating this whole thing with x, and then from the chain rule, this and this will cancel, and we're left with this dy, the integral of our y function with respect to y, and our integral of our f of x function with respect to x. Well, this y function is 1 over y. So let's jump into an example. So this first one here, solve the following differential equations. Dy dx equals x times y. So we've got to multiply both sides by 1 over y to get this. Now, I'm just going to leave that out because we'll just make that's simple. We already know how to do that. So 1 over y times dy dx equals x. So we've got this here. We now integrate with respect to x. So the integral of 1 over y dy dx. Notice that I've got the whole thing from this side. I've got all my terms are still in here, and then it's with respect. I didn't mean to change color. And then we've got with respect to x, and then this here is the integral of x with respect to x. Okay, chain rule here, they cancel out. We've got the derivative of 1 over y with respect to y, so we get ln absolute value of y equals, and then we've got x squared on 2 plus c. And then our next step here is, I'm going to have to jump up to the right, so I do apologise. Let's just move this. We can move this down a little bit to give ourselves more room. All right, so then we've got here in this next step, we raise it to an e, so it's going to be e ln absolute value of y equals e to the x squared on 2 plus, let me just have that up there, plus c up there. So they cancel out. We're going to have y equals e to the, now I'm going to leave this in here, plus or minus just for the minute, e to the x squared on 2, and then e to the c using our index laws. Now, rather than having these things in here, because they make it awkward, we've got two functions then, I'm going to swap them out for an a instead. So I'm just going to put a there, e x squared on 2. Now, this gives me the benefit of if I had a particular scenario, like a particular point, I can just put that in there. So if I had a coordinate of maybe x equals 0, let's just do it here. Actually, no, I'm not going to do it because we'll do it in a further example here. All right, our next example here, we've got dy dx equals 1 over y squared. So we would multiply by y squared to get the y on the other side. So we get y squared equals dy dx equals 1. We integrate to both sides. So we're going to get integral of y squared dy dx dx, and I'm just going to cross those dx's out, and the integral of 1 with respect to x, okay, this is going to give us y cubed on 3 equals x plus c, and then we would rearrange, so we multiply everything by 3. Now, this gives us y cubed equals 3x. Now, we could write 3c, but realistically, because we don't know what c is, we can just leave that. It's just going to be a constant when we finish, okay? And then we're going to do y equals the cube root of 3x plus c. That's our solution there. So that's it all done. Now, I'm just going to quickly come back up to this example here because there was a specific bit to it that I wanted to point out. Now, we had dy dx equals y plus 3, and I told you can't just take y. And the issue with this would become that we would end up with negative y plus dy dx equals 3. So when we did the integral here, you're not going to end up with the same chain rule that we need. We're going to end up with, if we do the integral with respect to x, we'd end up with negative y dx, and it doesn't have the dy to get rid of it. And then you'd end up with the integral of dy dx with respect to x, and that would just cancel out, and we'd be left getting a y there. So just make sure that the first step, you've got to remember that we are multiplying to get rid of get the y on the other side. All right.